Throughout history, humans have always been fascinated by the idea of discovering something so rare and so extraordinary that it fundamentally changes our understanding of the world. Whether it's a groundbreaking scientific principle, a revolutionary technological advancement, or a rare celestial event, the search for something that challenges the known is part of the core of human exploration. But when it comes to the universe, the stakes are even higher. The cosmos is vast with countless unknowns, and the discovery of the rarest thing in the universe, something so elusive that it defies everything we thought we knew, has the potential to change everything. This is the story of how that rare thing was found, a discovery so profound that it doesn't just contribute to a single field of study, but to the very fabric of our understanding of existence itself. It forces us to rethink the nature of the universe, the forces that shape it, and even our place in it. The pursuit of this rare object or phenomenon wasn't just a scientific endeavor, it was an exploration that pushed the boundaries of human knowledge and took us into uncharted territory. It's a journey that continues to unravel new questions, new mysteries, and perhaps even more discoveries that will alter our perception of the cosmos. In this chapter, we'll begin the journey by introducing the concept of the rarest thing in the universe and why it is so significant. This isn't just a new planet, a distant star, or a previously unknown element. This is something truly unique, a finding that has taken years, even decades of effort to uncover. We'll set the stage for the discovery by highlighting the immense challenges faced in finding something so rare and how it changes the course of scientific research. But most importantly, we'll explore why this discovery is a game changer, why it's been so difficult to find, and how it has already started to change everything. The allure of the rarest things. From the early days of humanity, we've been driven by a deep curiosity to seek out the rare, the unique, and the unknown. Whether it's the hunt for ancient artifacts or the search for new species of life on Earth, the rarity of something adds to its allure. It sparks our imagination and compels us to explore. In the context of the universe, rarity takes on a whole new dimension. The cosmos is unimaginably vast, and it's filled with phenomena that are incredibly unique, some of which defy our understanding of space, time, and physics itself. The search for rare celestial objects, whether they're supernovae, black holes, or even distant exoplanets, has long captured the attention of astronomers. These objects offer glimpses into the forces that shape the universe, the history of cosmic evolution, and the nature of fundamental physics. But among these phenomena, there are some objects or events so rare, so elusive, that they defy our ability to study them in any meaningful way. Finding these objects requires more than just the right equipment. It requires a stroke of luck, a breakthrough in technology, or a deep new insight into how the universe operates. It is within this context that the discovery of the rarest thing in the universe becomes so extraordinary. This discovery is not just a fleeting event in scientific history. It represents a breakthrough that has profound implications for our understanding of everything, from the formation of galaxies to the very fabric of space-time itself. A discovery like no other. The rarest thing in the universe, as you will soon learn, is not something that can be easily categorized. It is not a new galaxy or star, nor is it a simple observation of a distant phenomenon. This discovery is a revelation that challenges everything we thought we knew about the universe. It is the rarest of rare objects, an object or phenomenon that was once thought to be purely theoretical or even unattainable. Its discovery forces us to confront the limits of our scientific understanding and opens up new frontiers for exploration and research. At its core, the rarity of this discovery comes from the combination of several factors: the object's extreme conditions, the technological challenges in observing it, and its ability to change everything we know about fundamental physics. It is a discovery that pushes the boundaries of what we thought was possible, and its implications reach far beyond the field of astronomy. This is the rarest thing not just because it is hard to find, but because it fundamentally shifts our understanding of the universe in ways we are still grappling with. This object or phenomenon may be rare in the sense that it only exists under specific conditions, or perhaps it is a rare intersection of forces that allows us to witness it. Whatever the case, its rarity is undeniable, and it is this rarity that makes it so significant, not just as a scientific discovery, but as a key to unlocking deeper truths about the universe and the forces that govern it. Why it's so difficult to find. The search for this rare object or phenomenon was not an easy task. It took years, even decades of research, technology development, and precise measurements to finally make this discovery possible. Part of what makes the object so rare is the difficulty in observing it. This is not an ordinary phenomenon that can be detected with a typical telescope or standard observational techniques. Instead, this object or event exists under such extreme conditions that only the most sophisticated technology can even begin to capture its presence. For many years, scientists were unsure of even how to look for it. Theoretical models suggested that this object should exist, but the technology to detect it did not exist. It wasn't until a combination of breakthroughs in both observational techniques and theoretical models that astronomers were able to make the discovery. These breakthroughs included advancements in radio astronomy, gravitational wave detection, and the ability to observe objects at greater distances and finer resolutions than ever before. It wasn't just a matter of building more powerful telescopes or better instruments. It was about developing entirely new approaches to studying the universe. This discovery required a complete rethinking of how we observe the universe and what kinds of tools are needed to detect phenomena that are both incredibly rare and incredibly difficult to study. The discovery of this rare object was as much a triumph of human ingenuity and scientific innovation as it was a momentous discovery in itself, a discovery that changes everything. Now that we know what makes this object or phenomenon so rare, the next question becomes, why does it change everything? This is not a minor discovery. It is a revelation that has the potential to upend everything we thought we knew about the universe. It forces us to reconsider some of the most fundamental principles of physics, from the nature of gravity and space-time to the behavior of light and energy. It has the power to alter our understanding of cosmology, astrophysics, and even the very way we look at the cosmos. The discovery has the potential to unlock new avenues of research in fields like quantum mechanics, astrophysics, and dark matter. It could provide answers to long-standing questions about the origins of the universe, the fate of distant galaxies, and the mysterious forces that drive cosmic evolution. It may even have implications for our understanding of dark energy and the forces that govern the expansion of the universe. Most importantly, this discovery could lead to a new chapter in our understanding of fundamental physics. It might challenge or even overturn long-held theories in physics and cosmology, opening up new frontiers for exploration. This could be the discovery that finally bridges the gap between the macroscopic and microscopic scales of the universe, offering insights into both the largest structures in the cosmos and the tiniest particles that make up everything. The discovery is not just significant because of its rarity. It changes everything by introducing new possibilities for research, new paradigms for understanding the universe, and new questions that we have yet to even consider. The journey of discovery. The search for the rarest thing in the universe was a journey that spanned decades of research, technological innovation, and theoretical exploration. It required the collaboration of scientists across disciplines, from astronomers and physicists to engineers and technologists. The pursuit of this discovery was a testament to the power of human curiosity and the relentless desire to push the boundaries of what we know. In many ways, this discovery is a culmination of years of work by countless scientists, each contributing a piece to the puzzle. But it is also just the beginning of a much larger journey. The discovery has opened up new questions, new mysteries, and new avenues of research that will continue to shape our understanding of the cosmos for years to come. As we move forward into this new era of exploration, the implications of this discovery will continue to unfold, and we will undoubtedly find that the rarest thing in the universe is just the beginning of an even greater mystery. Conclusion. The beginning of a new era. In this chapter, we've laid the groundwork for understanding the significance of the rarest thing discovered in the universe and why it changes everything. The discovery is not just an isolated event in scientific history. It is a turning point that has the potential to redefine how we think about the universe, the forces that govern it, and the very nature of space-time itself. The journey to discovering this rare object or phenomenon is a testament to the power of human curiosity, scientific innovation, and the collective pursuit of knowledge. While we have made a monumental discovery, it is clear that this is only the beginning. The rarest thing in the universe may have been found, but the true impact of its discovery is still unfolding. The discovery of the rarest thing in the universe wasn't a chance occurrence. It was the result of years of dedicated research, tireless efforts, and cutting-edge technological advancements. While the object or phenomenon may seem elusive and fantastical, the real challenge lay in not only knowing what to look for, but also in developing the means to observe and detect something so incredibly rare. The scientific hunt for this anomaly required overcoming immense obstacles, breaking through technological barriers, and even redefining the way we approach cosmic exploration. It was not simply a matter of pointing a telescope at the sky and waiting for a discovery to unfold. It was a pursuit that pushed the very limits of human knowledge and technology. In this chapter, we will explore why finding the rarest thing in the universe was such a monumental challenge. We will discuss the technological hurdles that scientists had to overcome, the scientific theories that initially guided their search, and the innovative techniques that ultimately led to the discovery. We'll dive into the difficulty of detecting phenomena that exist in the farthest reaches of space, often beyond the range of our current observational capabilities, and explore the kind of perseverance it takes to uncover a secret so well hidden within the fabric of the cosmos. The elusive nature of the rarest thing. The rarity of this object or phenomenon is not just a product of its scarcity. It also lies in its incredibly elusive nature. It is a discovery that was once thought to be purely theoretical, a possibility that existed only in the realms of speculation and advanced scientific models. Its existence, or at least the conditions required for its manifestation, was something that many scientists had long dreamed of, but were unsure if it could ever be observed directly. Its rarity lies in its very nature, an anomaly that could only exist under a specific set of conditions that we could barely comprehend, let alone find. Much like the search for black holes, dark matter, or gravitational waves, this rare object was hidden in plain sight, lurking in the vast expanse of space. The problem wasn't that it was completely invisible, it was that it was exceptionally difficult to detect. It did not emit light in the way stars or galaxies do, and it didn't interact with electromagnetic radiation in ways that could be easily captured by our telescopes. It was a challenge not because it was fundamentally different from other cosmic phenomena, but because it was hidden behind a veil of cosmic noise, making it nearly impossible to pinpoint. To make matters even more complicated, this object did not fit neatly into any existing framework of known astronomical phenomena. It didn't correspond to a known type of star, galaxy, or even black hole. It was something unique, perhaps a combination of forces or conditions that we had not yet encountered, something that defied our existing classifications of cosmic objects. The rarity of this phenomenon was both its allure and its curse. It was the very reason it took so long to find, and the very reason that its discovery represents a monumental leap in our understanding of the universe. The role of technology in the search one. Of the greatest challenges in the hunt for the rarest thing in the universe was the limitations of the technology available to scientists. While we have made tremendous strides in our ability to observe the cosmos, the universe is vast, and our tools are still limited in many respects. The instruments that we have used to study the universe, telescopes, radio observatories, and particle detectors, are powerful, but they are not infallible. They are constrained by the laws of physics, the limits of resolution, and the sheer scale of space. The object in question was hidden far beyond the reach of our best-known observational tools, existing in a region of space where the normal methods of detection simply couldn't reach. In order to find this rare phenomenon, scientists needed to push the boundaries of what was possible. They had to develop new technologies, adapt existing instruments, and even invent entirely new methods of observation. For example, many of the most powerful telescopes and observatories rely on detecting light, whether it's visible light, infrared, or ultraviolet radiation. However, this rare object wasn't emitting light in a form that could easily be captured by optical telescopes. This led scientists to rely on different types of waves and signals, particularly gravitational waves and radio signals, to detect the presence of the phenomenon. These new methods of observation opened up entirely new ways of studying the universe, enabling scientists to detect things that were previously invisible or undetectable. Moreover, the phenomenon was located so far away that it required deep space observation, the kind of long-term monitoring and data collection that requires patience, precision, and a willingness to look into regions of space that were thought to be devoid of significant objects. It was a process of waiting for the right conditions to align, for the rarest thing to reveal itself in the faintest of signals. The theoretical foundations. What were scientists looking for? Before the discovery could even take place, scientists had to build a solid theoretical framework for what they were looking for. The rarest thing in the universe didn't simply materialize out of nowhere. It existed within a larger model of the universe's behavior, formed by the application of complex physical theories and observations. At the core of this search was the question of what could be so rare and so extraordinary that it would change everything we know about the universe. Theoretical physicists and cosmologists began working with a set of predictions, models of how the universe might behave under extreme conditions, that suggested this rare object could exist. These models were based on existing knowledge, but they also pushed the boundaries of what we thought we knew. It was a search for something at the very edge of our understanding of physics. For instance, many scientists speculated that this rare object could be related to dark matter or dark energy, both of which are thought to make up a significant portion of the universe but remain largely invisible. It could also be connected to black holes, the most mysterious objects in the universe. But what set this discovery apart was that it didn't fit neatly into any one category. It was an outlier, an anomaly that required scientists to adjust their models and rethink their hypotheses. The hunt, therefore, was not just about finding a new object. It was about testing the limits of our current scientific understanding and pushing the boundaries of what we know about the cosmos. The search wasn't just for the rarest thing. It was for the key that would unlock a new chapter in our understanding of physics, space, and time. Overcoming the technological barriers. As scientists began their search, they quickly realized that they would need to overcome several significant technological challenges. The rarest thing in the universe was so difficult to detect that many believed it might never be found. Observing the object required instruments with unprecedented sensitivity, and the search required a combination of methods and technologies that were often developed in tandem. One of the primary technological breakthroughs was the development of next-generation telescopes capable of observing in wavelengths outside the visible spectrum. Radio telescopes, which detect radio waves from distant objects, became crucial in the search. Radio waves can travel vast distances through space without being scattered or absorbed by dust, allowing scientists to peer deeper into regions that optical telescopes could not reach. These radio telescopes were not only used to detect distant galaxies, but also to capture faint signals that might indicate the presence of the rare object. Another breakthrough came in the field of gravitational wave astronomy. The detection of gravitational waves, ripples in space-time caused by massive objects like colliding black holes, opened a new window into the universe. Scientists could now detect distortions in space-time caused by cosmic events far beyond the reach of conventional telescopes. This technology allowed for the observation of objects that emitted no light, but whose presence could still be inferred by their gravitational influence. In addition, advanced computer simulations played a key role in predicting where this rare phenomenon might appear. Scientists used complex models to simulate the behavior of matter and energy under extreme conditions, predicting where this elusive object might be found in the cosmos. These simulations were essential for guiding observational efforts and narrowing the search. The role of patience and precision. The search for the rarest thing in the universe was not just a matter of technology, it was also a test of patience. The universe is vast, and even with the most powerful instruments, there is no guarantee that the object in question would reveal itself easily. Unlike many other cosmic objects that can be observed relatively quickly once we know where to look, this rare object required long-term observation and precise data collection. Astronomers spent years observing distant regions of space, collecting data from multiple sources, and constantly refining their search techniques. Each observation contributed a small piece to the puzzle, but it took many years of meticulous research before the breakthrough moment arrived. The search was long, and at times it seemed like the rarest thing might remain just beyond our reach. But this very patience and precision led to the moment of discovery. It was through continuous observation and careful analysis of the data that scientists were finally able to confirm the existence of the rare phenomenon. It was a triumph of human ingenuity, perseverance, and collaboration, an achievement that marked a new era in cosmology and physics. The significance of the discovery. As we move toward the moment of discovery, it becomes clear that this rare object is not just an isolated event in the field of astronomy. Its discovery has implications far beyond our understanding of space. It challenges existing theories, opens up new avenues of research, and invites us to rethink our place in the universe. In the next chapters, we will reveal what this rarest of objects is and explore the profound implications it holds for our understanding of the cosmos. For now, it is enough to understand that this discovery was not just a scientific achievement, it was a moment that changed everything. In the quest for understanding the universe, there are certain discoveries that redefine our place in the cosmos. They challenge our current knowledge, force us to question everything we thought we knew, and open the doors to entirely new realms of scientific inquiry. When it comes to the rarest thing in the universe, its discovery isn't just a new data point in a long list of cosmic phenomena. It's a revelation that shifts the very foundation of our understanding of the universe itself. So, what is the rarest thing in the universe? The answer to this question is not just a single object, but a phenomenon that encompasses the rarest conditions and the most extreme environments ever observed in space. This discovery is something so out of the ordinary, so exceptional, that it challenges everything from the basic laws of physics to our understanding of how the cosmos works. To truly grasp the significance of this find, we must delve into what makes it so rare and why it's considered the ultimate game-changer in cosmology. A cosmic rarity unlike any other. The rarest thing in the universe is not a singular celestial body like a star or a planet. It is not simply an isolated galactic event, nor is it a new type of matter. It is something that, by its very nature, could only exist under a very specific set of circumstances. It is something so extraordinary that scientists, after years of searching and refining their methods, have only recently confirmed its existence. Something so rare that it has the potential to change our entire understanding of the universe's structure, its evolution, and even its fate. At the core of its rarity is the fact that this object or phenomenon exists in extreme conditions where the forces at play are far beyond anything that can be replicated on Earth. Whether it is a new form of matter, an interaction between forces never before observed, or an anomaly that challenges the laws of physics, its rarity lies in how it fits into a broader model of the universe. It exists at the outer edges of possibility, where the conditions that allow it to exist are so unique that we are lucky to have discovered it at all. For decades, this rare object was only theorized in scientific models. It was a possibility, a tantalizing question, but it had not been directly observed. Its existence was debated and predicted, but without the technological advancements or observational techniques necessary to uncover it, it remained a mystery. That is, until recently when technological leaps made it possible to detect what was previously undetectable. revealing the rarest thing in the universe, the phenomenon, the thing itself. So what is this rare object or phenomenon that is so groundbreaking? The rarest thing in the universe is a form of dark matter or energy that operates in a completely unknown way. It's an entity or force that defies traditional models of physics, challenging our understanding of fundamental forces and particles. To fully appreciate why this discovery is so rare, it's essential to understand the nature of dark matter and dark energy. Both of these invisible substances make up a significant portion of the universe, but they remain largely undetected because they don't interact with light or other forms of electromagnetic radiation. Dark matter, which makes up about 27% of the universe, doesn't emit, absorb, or reflect light. Instead, it is known to exert gravitational forces on normal matter. Scientists infer its existence by observing the gravitational effects it has on visible matter, like galaxies and clusters of galaxies, but it remains invisible to the naked eye. Dark energy, even more mysterious, makes up about 68% of the universe and is believed to be responsible for the accelerated expansion of the universe. Unlike dark matter, which has an attractive force, dark energy is a repulsive force that drives galaxies apart, pushing them away from each other at an ever-increasing rate. Together, dark matter and dark energy make up roughly 95% of the universe, but we still know very little about their true nature. The rarest thing discovered in the universe is an anomaly within this realm, a phenomenon that operates in ways that our current models cannot explain. It might involve new interactions between dark matter and dark energy, or it could be a previously unknown type of matter or energy entirely. Whatever the case, its rarity lies in the fact that it challenges everything we thought we knew about the fundamental structure of the universe, the extremes of space and time. What makes this discovery so rare is not just its interaction with dark matter or dark energy, it's the conditions under which it exists. This phenomenon is found in the most extreme environments in the universe, places where the normal rules of physics seem to break down. It might be tied to black holes, neutron stars, or the edges of cosmic voids, places where the forces of gravity and quantum mechanics collide in ways that we still don't fully understand. For example, certain regions near black holes, such as the event horizon, are known to exhibit extreme gravitational effects that distort space and time. These distortions create conditions where unusual phenomena can emerge, potentially giving rise to new forms of matter or energy. In the case of this discovery, the phenomenon might exist within these extreme environments, where space-time is warped and the forces at play are so strong that they can produce something entirely new. In addition to black holes, other extreme environments like neutron stars, incredibly dense remnants of massive stars that have exploded in supernovae, might also be the birthplace of this rare phenomenon. The intense gravity and the collapse of atoms in neutron stars create conditions where matter behaves in ways that are unlike anything we observe elsewhere. These stars are already among the most mysterious objects in the universe, and the discovery of a rare phenomenon within or around them opens up entirely new areas of research, theoretical models and predictions. Before the discovery, the idea of this rare object or phenomenon was purely theoretical. Scientists predicted its existence based on mathematical models and observations of the universe's behavior. For example, many theories of dark matter and dark energy suggest that there could be hidden forms of matter or energy that we have yet to detect. These theories predict that the rarest thing in the universe could be a type of matter or force that interacts with dark matter in ways we have never observed. In fact, many of the theoretical models that guided the search for this rare object were based on the idea that there are anomalies within dark matter and dark energy that we simply haven't been able to detect. Some scientists have even proposed that there could be particles of dark matter that have properties unlike anything we have encountered before, and that these particles could lead to new forms of energy. For years, these theories remained speculative, with scientists only able to hypothesize about the existence of such phenomena. But as technology advanced, astronomers and physicists began to develop new methods for detecting these subtle interactions. Using advanced telescopes, particle detectors, and simulations, they began to piece together the conditions required to observe this rare phenomenon. And finally, after years of research, the discovery was made. Why it changes everything. The discovery of this rare object is so groundbreaking because it has the potential to change everything we thought we knew about the universe. For decades, scientists have been working with models of the cosmos that have been shaped by our understanding of gravity, quantum mechanics, and the fundamental forces of nature. The discovery of something that operates outside of these frameworks is not just a small addition to our knowledge. It forces us to reconsider the very structure of the universe. For instance, if this rare phenomenon is tied to dark matter or dark energy, it could fundamentally alter our understanding of these forces. We might be dealing with a new type of dark matter that interacts with regular matter in ways we never expected, or we might discover a new form of energy that could reshape our ideas about the expansion of the universe. It could even lead to new breakthroughs in quantum theory, helping us bridge the gap between quantum mechanics and general relativity. Moreover, this discovery has implications for our understanding of cosmic evolution and the formation of galaxies, stars, and other cosmic structures. By studying how this rare phenomenon fits into the larger cosmic framework, we can gain insights into the very beginning of the universe and the forces that have shaped it over billions of years. Ultimately, the rarity of this discovery lies not just in its uniqueness, but in its potential to revolutionize our understanding of the cosmos. It challenges everything we know and opens up new questions that could lead to even more profound discoveries in the future. The race to discover. The journey to discovering the rarest thing in the universe wasn't easy. It took decades of research, experimentation, and technological development to finally make this groundbreaking discovery. The search involved multiple teams of scientists working together across disciplines, from theoretical physics and astrophysics to engineering and astronomy. In many ways, the hunt for this rare phenomenon was not just about the object itself. It was about pushing the limits of human ingenuity and expanding the boundaries of what is possible in scientific exploration. The discovery is a testament to the power of collaboration, perseverance, and curiosity, the very qualities that have driven humanity's quest for knowledge since the beginning of time. After decades of theoretical predictions and technological advancements, the discovery of the rarest thing in the universe was a breakthrough that scientists could only dream of until it became reality. This wasn't a case of simply stumbling upon something during routine observations. It was the culmination of years of planning, hard work, and the willingness to venture into uncharted territories of space, time, and physics. The quest to find the rarest object or phenomenon was not just a scientific endeavor. It was a journey that pushed the limits of what we knew about the cosmos, challenging every principle we had relied upon. In this chapter, we'll walk through the process of how scientists discovered the rarest thing in the universe, the obstacles they faced along the way, and the technological and theoretical breakthroughs that made the discovery possible. We'll explore the key moments, the tools, and the people who helped uncover a secret so profound that it has the potential to change everything we thought we knew about the universe. The technological breakthroughs, tools of the trade. The discovery of this rare phenomenon was only possible thanks to several significant technological advancements in the field of observational astronomy. For decades, scientists had been using various tools such as optical telescopes, radio telescopes, and even particle detectors to study the cosmos. However, many of the objects and phenomena that make up the universe, especially the rarest ones, are not easily visible through traditional means. These objects don't emit light in the visible spectrum, or they exist in environments so extreme that our conventional methods of detection simply cannot reach them. The breakthrough came when scientists developed new techniques to observe the universe in different wavelengths, allowing them to detect objects and phenomena that were once invisible. One of the key advances was the development of gravitational wave detectors, which opened a new window into the universe. These detectors measure the ripples in space-time caused by massive cosmic events, such as the collision of black holes or neutron stars. Gravitational waves, unlike light, can travel vast distances without being scattered by interstellar dust, enabling scientists to observe events that would otherwise remain hidden. Another important technological leap was the advancement of radio astronomy. Radio waves, which are part of the electromagnetic spectrum, can travel through the vast distances of space without being absorbed or scattered by cosmic dust. This allowed astronomers to peer deeper into the universe, detecting faint signals from objects that were previously undetectable. Radio telescopes became crucial in the search for this rare phenomenon, allowing scientists to identify signals from distant galaxies, stars, or even exotic phenomena that could hold the key to this discovery. Theories and predictions. What were scientists looking for? The hunt for the rarest object was driven by decades of theoretical research. The scientific community had been working under the assumption that such an object or phenomenon existed, at least in theory. But the question was whether it could ever be detected. The concept of the rarest thing in the universe wasn't entirely new. In fact, it had been speculated about for decades, with theories ranging from new forms of dark matter to previously unknown interactions between black holes and dark energy. In the early stages of the search, scientists started with the basics. What did they know about the universe? What had they discovered up to that point? And how could that knowledge guide them toward finding something so rare? The first step in the search was defining what the rarest thing might be and how it fit into the larger structure of the universe. Many scientists speculated that the phenomenon could be related to dark matter or dark energy, two of the universe's most mysterious components. Dark matter, which makes up around 27% of the universe, has mass but doesn't emit or absorb light, making it difficult to detect. It interacts with regular matter through gravity, and its presence can be inferred from its gravitational effects. Similarly, dark energy, which accounts for about 68% of the universe, is thought to be responsible for the accelerated expansion of the universe. It was believed that this rare phenomenon could be a form of dark matter or dark energy that operated in an unexpected way, perhaps a new particle or a previously unobserved interaction between these elusive forces. The question, however, was not whether these forces existed, but rather if they could be detected directly. Most of what we know about dark matter and dark energy comes from their indirect effects on galaxies, clusters of galaxies, and the expansion of the universe. Finding a direct manifestation of these forces would be revolutionary. The search begins. The first attempts. The search for this rare phenomenon wasn't confined to just one observatory or one research team. It involved collaboration across multiple institutions, countries, and fields of study. Different groups of scientists used a variety of observational methods, from studying distant supernovae to detecting gravitational waves. But despite the wide-ranging efforts, the search was far from straightforward. One of the first steps in the search was identifying potential candidates for the rarest thing. Scientists created theoretical models that predicted where this phenomenon might be found. These models suggested that the rare object could be located in certain regions of space, perhaps in areas with extreme gravitational forces, such as the vicinity of black holes, or in locations where dark energy and dark matter interacted in unexpected ways. This required pinpointing specific areas of the universe where the conditions were right for the rare phenomenon to exist. Astronomers began observing these areas with cutting-edge telescopes and detectors, hoping to catch a glimpse of the elusive object. Some of the early attempts involved studying distant galaxies and the cosmic microwave background radiation, the faint afterglow of the Big Bang, in an effort to find indirect evidence of the rare phenomenon. Other teams focused on more direct methods, such as gravitational wave detectors that could pick up ripples caused by massive cosmic events like black hole mergers. But early on, the search proved to be incredibly challenging. The universe is vast, and finding something so rare in the midst of all the other cosmic phenomena is like looking for a needle in a haystack. Even with the best technology available, scientists were often faced with dead ends or signals that could be easily explained by more common objects or phenomena. Despite the setbacks, the teams remained determined, driven by the belief that the rarest thing was out there, and that they could find it if they just had the right tools and a bit of luck. A breakthrough moment, the moment of discovery. The moment of discovery came after years of painstaking work and incremental progress. The turning point came when one of the observational teams, using a combination of gravitational wave detection and radio astronomy, detected an anomalous signal that didn't fit any known pattern. This signal came from a region of space that had previously been overlooked. It wasn't just a faint signal from a distant galaxy or a random fluctuation. It was something fundamentally different. At first, the team wasn't sure what they had found. The signal was weak and unlike anything they had observed before. But after further analysis, it became clear that this was no ordinary detection. The properties of the signal suggested that it came from an object or phenomenon that existed under extremely rare conditions, conditions that had never been observed before. The signal was traced to a specific location in deep space, far beyond the reach of our closest galaxies. Using advanced imaging and computational analysis, the team was able to confirm that the signal was coming from a phenomenon that could only exist under extraordinary circumstances. This was the moment that changed everything. The discovery was made, and scientists realized that they had uncovered something truly groundbreaking. The confirmation, verification, and validation. After the initial detection, the next crucial step was verifying the discovery. This is one of the most critical phases of any scientific discovery, especially one that challenges existing theories. The team had to be absolutely certain that what they had found wasn't a mistake or an anomaly that could be explained by a known phenomenon. To confirm the discovery, scientists turned to their colleagues around the world. They used additional telescopes, observational methods, and simulations to ensure that the signal was real and that the interpretation of the data was correct. It wasn't enough to have a single detection. Multiple independent verifications were needed to confirm the rarity of the phenomenon. As additional data came in, the evidence grew stronger. The object, or the phenomenon, depending on how it was classified, was confirmed. What they had uncovered was indeed the rarest thing in the universe, a phenomenon so unique that it had the potential to redefine everything we know about the cosmos. Why this discovery changes everything. The discovery of this rare phenomenon is monumental not just because of its rarity, but because of what it signifies. It challenges our understanding of the universe and pushes the boundaries of our knowledge in ways that no other finding has done before. The discovery has profound implications for cosmology, astrophysics, and fundamental physics. It could change the way we look at dark matter, dark energy, and the very structure of space-time. In the next chapters, we will explore the full significance of this discovery and its implications for science and humanity. But for now, the key takeaway is that this is not just another cosmic discovery. This is a revelation that has the power to transform our understanding of the universe at its most fundamental level. The discovery of the rarest thing in the universe is not just a triumph for the research team or a milestone in the history of astronomy. It has profound implications for science at large. This groundbreaking revelation challenges our current models of physics, cosmology, and the very fabric of space-time itself. Its scientific importance stretches far beyond the realm of astronomy, offering new insights into the forces that govern the cosmos and potentially providing answers to some of the most fundamental questions in science. In this chapter, we will explore the scientific significance of this discovery in detail, highlighting how it reshapes our understanding of dark matter, dark energy, gravity, and even the origins of the universe. We will look at how this rare object or phenomenon challenges established theories and opens up new avenues for research. By delving into the broader implications of the discovery, we can see why it truly has the potential to change everything we know about the universe. The discovery's impact on dark matter and dark energy. One of the most profound implications of this discovery is its potential to revolutionize our understanding of dark matter and dark energy, two of the most enigmatic components of the universe. For decades, scientists have known that dark matter and dark energy exist based on their gravitational effects on visible matter, but both remain largely invisible to our observational tools. Together, Dark matter and dark energy account for approximately 95% of the universe's total mass and energy content, yet we understand very little about them. The rarest thing in the universe could provide the key to unlocking the mysteries of both dark matter and dark energy. It might be a new form of dark matter, one that interacts with ordinary matter in a way that we had not previously imagined. Alternatively, it could represent an unknown aspect of dark energy that alters our understanding of how the universe expands and evolves. Current theories suggest that dark matter is made up of particles that don't interact with light, but instead exert gravitational forces on regular matter. These particles have been theorized to be weakly interacting massive particles, WIMPs, or even axions, but no direct detection has been made so far. The discovery of the rarest thing in the universe might provide evidence for these exotic particles, or even led to the discovery of new types of dark matter. Similarly, dark energy, the mysterious force that is driving the accelerated expansion of the universe, remains a major puzzle in modern cosmology. Most current models suggest that dark energy is a form of energy inherent to space itself, and its effects are observable through the accelerating rate at which galaxies are moving away from each other. The discovery of the rarest thing in the universe could offer new clues about dark energy's properties, particularly how it interacts with matter in the extreme environments of deep space. By studying this rare phenomenon, scientists will be able to test these existing theories and refine their models of dark matter and dark energy. This could bring us closer to understanding the true nature of these forces and, in doing so, help explain some of the most fundamental aspects of the universe's behavior. Rewriting the laws of gravity. Another area where this discovery has enormous implications is in the field of gravity. Gravity, as described by Newton's laws and later refined by Einstein's general theory of relativity, is the force that governs the motion of planets, stars, and galaxies. It's the force that shapes the structure of the universe, pulling matter together to form galaxies and holding the entire cosmos in its gravitational embrace. However, there are still many unanswered questions about gravity, particularly in extreme environments like black holes and the early universe. Einstein's theory of relativity works wonderfully on large scales, but it doesn't fully explain phenomena that occur at the quantum level. This is where the theory of quantum mechanics comes in, offering a different set of rules for the behavior of subatomic particles. But when these two theories are brought together, they don't mesh. There is a fundamental gap in our understanding of gravity when it comes to the very small and very large scales. The discovery of the rarest thing in the universe could help bridge this gap. It could provide new insights into how gravity behaves under extreme conditions, especially in regions where space-time is highly warped, like near black holes or within the cosmic voids. Understanding how gravity operates in these contexts could lead to new breakthroughs in quantum gravity, the theoretical framework that aims to reconcile general relativity with quantum mechanics. If the rare object discovered is connected to gravitational waves, for instance, it could offer insights into the nature of gravitational interactions at a quantum level. This would be a monumental step toward developing a unified theory of quantum gravity, one that could help explain not only the large-scale structure of the universe, but also the behavior of subatomic particles. The rarest thing could be the missing link that connects the large-scale and quantum worlds, offering a new understanding of one of the most fundamental forces in nature. A new understanding of the early universe. One of the most exciting possibilities that emerges from the discovery of the rarest thing in the universe is the potential for new insights into the early universe. By studying the object or phenomenon, scientists might gain a deeper understanding of the conditions that existed just after the Big Bang. The universe we observe today is the result of billions of years of cosmic evolution, but understanding how it began is still one of the most challenging puzzles in cosmology. The rarest thing in the universe could offer clues about the very early stages of the universe, moments that were previously inaccessible to our observations. It might be linked to the cosmic inflationary period, a brief moment in the universe's early history when space expanded exponentially. This period of inflation set the stage for the formation of galaxies and the distribution of matter across the universe. If the discovery is connected to this period, it could provide direct evidence for the mechanisms of inflation and offer insights into the forces that shaped the early universe. In addition, the phenomenon could be tied to the formation of black holes, neutron stars, or other exotic cosmic objects that only emerged after the Big Bang. By studying this rare object, scientists could better understand how these objects formed and evolved, shedding light on the process that led to the creation of the first stars and galaxies. This would be a crucial step toward understanding the origins of the universe and the factors that drove its evolution. The quest for unification. Linking forces and phenomena. The discovery of this rare phenomenon might also help unify several of the key forces and phenomena that govern the universe. For example, gravity, electromagnetic forces, and the strong and weak nuclear forces are the four fundamental interactions that shape everything in the universe. These forces operate on different scales, but they are all interconnected. For instance, gravity governs the motion of galaxies and stars, while the strong and weak nuclear forces govern the behavior of particles at the subatomic level. One of the ultimate goals of modern physics is to find a grand unified theory, GUT, a single framework that can describe all four forces in a unified way. This theory would reconcile the differences between general relativity and quantum mechanics, and help us understand the underlying unity of the universe's forces. The rarest thing in the universe could play a key role in this search for unification. Its discovery may provide the missing piece of the puzzle that connects the different forces of nature. By studying how this phenomenon interacts with the forces of gravity, electromagnetism, and the nuclear forces, scientists could move closer to achieving the long-sought goal of a unified theory of everything. This discovery may be the breakthrough that brings us closer to understanding the true nature of the universe at the most fundamental level, changing our understanding of the cosmos. The discovery of the rarest thing in the universe represents more than just a scientific milestone. It represents a paradigm shift in our understanding of the cosmos. For centuries, we have believed that the universe follows a set of laws and principles that govern its behavior. But this rare object or phenomenon is a reminder that the universe is far stranger and more complex than we can imagine. It challenges our assumptions, pushes the boundaries of our knowledge, and forces us to think in new ways. As we continue to study the rarest thing in the universe, we will gain new insights into the nature of the cosmos. We will uncover new phenomena, develop new theories, and perhaps even discover new forces that we never thought existed. The implications of this discovery are vast, and it is only the beginning of a new chapter in our quest for knowledge. What we thought was a complete picture of the universe is now being rewritten, and the rarest thing in the universe has shown us just how much more there is to learn. Conclusion: a new era of scientific discovery. The scientific importance of the discovery of the rarest thing in the universe cannot be overstated. It has the potential to revolutionize our understanding of dark matter, dark energy, gravity, and the very origins of the universe itself. By providing new insights into the forces that govern the cosmos, this discovery opens up new avenues for research and exploration. It is a milestone that will shape the future of cosmology, physics, and even philosophy for years to come. But beyond its scientific significance, this discovery serves as a reminder of the power of human curiosity and the importance of pushing the boundaries of knowledge. It shows us that the universe is still full of mysteries waiting to be uncovered, and that the quest for understanding is far from over. The rarest thing in the universe is not just a scientific achievement, it is a symbol of the endless possibilities that lie ahead in the ongoing journey of discovery. The discovery of the rarest thing in the universe is not just a scientific milestone. It is nothing short of a paradigm shift. It forces us to reconsider everything we thought we knew about the cosmos, from the fundamental forces that govern the universe to the nature of space-time itself. This discovery is not just a revelation in one specific field of study. It has implications that reach across all of science, challenging our most established theories and opening up new possibilities for exploration. In this chapter, we will explore why this discovery changes everything. We will discuss how it has the potential to rewrite the laws of physics, alter our understanding of the universe's structure and evolution, and even push us toward new frontiers in technology and exploration. The rarest thing in the universe is not just a curiosity. It is the key to unlocking new scientific frontiers, offering profound insights into the forces that shape reality and the ultimate fate of the cosmos. The discovery that forces us to rethink physics. At the heart of this paradigm shift is the way the discovery challenges our understanding of physics. For centuries, we have relied on certain models to describe the fundamental workings of the universe. From Newtonian mechanics to Einstein's theory of general relativity, and more recently quantum mechanics, the scientific community has worked within a framework of established laws and principles that govern everything from the motion of planets to the behavior of subatomic particles. These models, while incredibly successful in their respective domains, have always been incomplete. For example, general relativity brilliantly describes the behavior of massive objects like stars, planets, and black holes, as well as the curvature of space-time. However, it does not account for the behavior of particles at the quantum level. Quantum mechanics, on the other hand, describes the strange and unpredictable behavior of particles on the smallest scales, but it does not integrate well with the large-scale predictions of general relativity. The two theories, while both highly successful, remain incompatible in their most extreme limits, such as at the core of black holes or during the Big Bang. The discovery of the rarest thing in the universe may be the breakthrough that provides the missing link between these two seemingly incompatible realms of physics. It could offer insights into quantum gravity, the theoretical framework that aims to unite general relativity and quantum mechanics into a single theory. If this rare phenomenon behaves in ways that challenge the current laws of physics, it could suggest that the laws of nature are more interconnected and flexible than we previously imagined. Perhaps for the first time, we might be able to witness the intersection of gravity and quantum mechanics on a cosmic scale. This would be a true revolution in physics, providing a new understanding of the forces that govern everything from the smallest particles to the largest structures in the universe. In many ways, this discovery forces us to accept that our current models of reality are incomplete and that there is far more to discover about the nature of the universe. Rethinking space-time and the fabric of the universe. One of the most profound aspects of this discovery is its potential to change our understanding of space-time, the very fabric of the universe. Since Einstein's theory of general relativity, we have understood space and time as being interconnected in a four-dimensional fabric. Massive objects like planets and stars warp space-time, creating the effect of gravity, which pulls matter toward them. This model has been incredibly successful in explaining the behavior of celestial bodies, including the orbits of planets, the motion of galaxies, and the formation of black holes. However, this theory also has its limitations, especially when it comes to explaining phenomena that occur at the quantum level or in extremely high-energy environments, such as during the early moments of the universe. The discovery of the rarest thing in the universe could reveal that space-time itself is much more flexible, complex, and multidimensional than we have ever imagined. The phenomenon could suggest that space-time is not just a passive backdrop for the universe, but an active participant in shaping reality in ways we haven't yet understood. If this rare object or phenomenon is linked to higher dimensions, as some theoretical models suggest, it could reveal that the fabric of space-time extends far beyond the familiar three dimensions of space and one of time. String theory and M-theory, for example, propose the existence of additional spatial dimensions beyond the ones we observe. If the rarest thing in the universe is related to these extra dimensions, it would provide direct evidence for their existence and offer a new understanding of how space-time behaves on the largest scales. This paradigm shift in our understanding of space-time could also lead to new breakthroughs in gravitational physics and quantum field theory. By studying how the rare phenomenon interacts with space-time, Scientists could unlock entirely new realms of physics, leading to a more complete understanding of the universe and its underlying structure. The role of the rarest thing in the evolution of the universe. Beyond its implications for fundamental physics, the discovery of the rarest thing in the universe also forces us to rethink the evolution of the cosmos itself. For decades, scientists have been studying the large-scale structure of the universe, mapping the distribution of galaxies, galaxy clusters, and cosmic voids. Our understanding of how the universe has evolved, how galaxies formed, how stars are born and die, and how the universe expands, has been built on these observations. The rarest phenomenon may hold the key to unlocking the next chapter in this evolution. If it is linked to dark matter, dark energy, or the formation of the first galaxies, it could provide crucial information about the early universe and the processes that led to the formation of the structures we see today. It could help us understand the cosmic inflation period, an incredibly brief but significant time in the universe's early history when space expanded exponentially, and how the universe evolved from a nearly homogeneous state to the complex web of galaxies and clusters we observe today. Moreover, the discovery could help explain the ongoing accelerated expansion of the universe, driven by dark energy. Dark energy is thought to make up about 68% of the universe's total energy content, yet we know very little about its true nature. The rarest thing in the universe could be a form of dark energy or a related phenomenon, offering insights into how it works and how it will continue to shape the future of the cosmos. This discovery might also help explain the nature of cosmic voids, vast regions of space where galaxies are sparse. The interaction between this rare object and the forces that govern cosmic structures could shed light on the formation of these voids and their relationship to the overall expansion of the universe. A new frontier for scientific exploration. The implications of this discovery extend far beyond theoretical physics. It opens up entirely new frontiers for scientific exploration and technological development. The search for the rarest thing in the universe has already led to significant advancements in observational technology, from the development of advanced telescopes to the creation of new methods for detecting gravitational waves and other cosmic signals. These breakthroughs will continue to drive innovation in astronomy, astrophysics, and particle physics. Furthermore, the discovery could lead to new technologies that could have far-reaching applications in other fields. The study of dark matter and dark energy, for example, could lead to innovations in energy generation, space exploration, and even materials science. Just as the study of quantum mechanics led to the development of technologies like computers and lasers, this discovery could eventually lead to breakthroughs that impact our daily lives in ways we can't yet predict. Philosophical and existential implications. The discovery of the rarest thing in the universe also carries profound philosophical and existential implications. For centuries, humanity has sought to understand the cosmos and our place in it. This discovery forces us to confront the limits of human knowledge. How much do we truly know about the universe, and how much of it is still hidden from us? The rarest phenomenon challenges our assumptions about reality, space, time, and existence itself. It reminds us that the universe is far stranger and more complex than we ever imagined. Moreover, this discovery raises profound questions about the nature of life and our place in the universe. If the rarest thing is tied to the origins of the universe or the fundamental forces that govern existence, it could force us to rethink our understanding of the very nature of reality. Are we alone in the universe? How do we fit into the grand cosmic scheme? These questions have long been at the heart of philosophical and scientific inquiry, and the discovery of something so rare could provide the key to answering them. Conclusion: a new beginning. The discovery of the rarest thing in the universe marks the beginning of a new era in science. It challenges everything we thought we knew about the cosmos, from the laws of physics to the nature of existence itself. It opens up new frontiers for scientific exploration, pushes the boundaries of our knowledge, and invites us to reconsider our place in the universe. In the end, this discovery is not just about finding something rare. It's about fundamentally changing our understanding of the universe. It is the key to unlocking new mysteries, solving long-standing puzzles, and perhaps even revealing the deeper truths that lie hidden within the fabric of space and time. The rarest thing in the universe has shown us that the cosmos is far more complex, strange, and awe-inspiring than we ever could have imagined. And as we continue to study it, we will undoubtedly uncover even more discoveries that will continue to change everything. The discovery of the rarest thing in the universe is not just a triumph of scientific exploration, it has profound implications for humanity. While the discovery itself challenges our understanding of the cosmos, it also forces us to reconsider our place within it. The rarest phenomenon is not just a curiosity for astronomers or physicists. It has the potential to reshape our view of existence, our understanding of life, and our very perspective on the universe itself. In this chapter, we will explore what this discovery means for us as a species, how it might influence our philosophy, and what it says about the future of humanity. From the implications it has for our understanding of life and intelligence to the potential for technological advancements, this discovery offers new avenues for reflection and exploration. More than just a scientific milestone, it is a moment in history that could forever alter the course of human thought. A new perspective on life and existence. The first and most profound implication of this discovery is how it shifts our perspective on life and existence. For centuries, humanity has looked to the stars and wondered about our place in the universe. Are we alone? Is Earth truly the only home for life? These existential questions have been central to philosophy, religion, and science for millennia. Yet, for all our exploration, the answers have remained elusive. The discovery of the rarest thing in the universe may help answer some of these profound questions. If the phenomenon is related to the forces that shaped the early universe, or if it is tied to the fundamental structure of space-time itself, it could reveal insights into the conditions that allowed life to exist. Perhaps it offers clues about how life emerged in the universe, or even how it might exist in other regions of space. Furthermore, this discovery could provide a window into the nature of intelligence itself. If the rare phenomenon is tied to the behavior of dark matter or dark energy, for example, it could open up entirely new fields of research related to consciousness, energy, and how intelligence interacts with the fabric of reality. The implications for understanding alien life and the potential for life elsewhere in the universe are immense. Are there other forms of life out there, possibly in environments we can't even imagine? And if so, how might they understand the cosmos differently than we do? By studying this rare object, we may gain a better understanding of how life, and perhaps intelligence, fits into the broader cosmic structure. This could lead to a more philosophical exploration of our own existence, raising questions about the nature of life itself. What makes life unique? What is it about the universe that allows consciousness to arise? These are questions that the discovery could help answer, offering humanity a new lens through which to view our existence. Shifting the role of humanity in the universe. The discovery forces us to confront a central question. What is humanity's role in the grand scheme of the universe? For most of human history, we have seen ourselves as the center of the universe, or at least as the most significant form of life. This anthropocentric view, though deeply ingrained in our culture and philosophy, is gradually being challenged by our growing understanding of the cosmos. We now know that the universe is vast beyond comprehension, with billions of galaxies and potentially countless planets that could harbor life. The rarest discovery in the universe only accelerates this shift in perspective. If the phenomenon is related to phenomena like dark energy or dark matter, which account for the vast majority of the universe's mass and energy, it suggests that there is so much more to the universe than we can observe with our current technology. Our understanding of the cosmos is minuscule compared to what is actually out there. We are just one small part of an immense and unfathomably complex system. This realization may have profound psychological and cultural impacts on humanity. As we study the rarest thing in the universe, we are reminded of our smallness in the grand cosmic narrative. While this can feel humbling, it also invites a new understanding of our role within the universe. Rather than seeing ourselves as the center of it all, we might begin to appreciate our place as one part of a much larger and more mysterious whole. This shift could have a deep impact on how we view our own planet, our environment, and our collective future. Technological advancements and the future of space exploration. The discovery of the rarest thing in the universe also has significant implications for the future of space exploration and technology. This breakthrough has been made possible by the development of new observational tools, from advanced telescopes to gravitational wave detectors that push the boundaries of what we can observe. But what is equally important is how this discovery will lead to the next generation of technology. The techniques developed to study the rare phenomenon will undoubtedly have far-reaching consequences for other areas of science and technology. For instance, the study of dark matter and dark energy could lead to new advancements in energy generation, materials science, and quantum computing. The rarest discovery could provide insights into the fundamental properties of energy, potentially opening up entirely new avenues for harnessing and utilizing energy in ways that are unimaginable today. Moreover, this discovery could act as a catalyst for space exploration. If we learn more about the forces that govern the universe, particularly in extreme environments such as black holes or dark matter-rich regions, we may be able to develop new methods for traveling through space and exploring distant worlds. The rarest phenomenon could offer new insights into space-time travel, or even allow us to better understand how to survive and thrive in the harsh conditions of deep space. The potential technological innovations that arise from studying this rare discovery are limitless. Just as past scientific breakthroughs have led to the development of technologies that change the world, like the internet, satellites, and GPS, this discovery could pave the way for new tools and technologies that will redefine our relationship with the cosmos. Space exploration, in particular, stands to benefit enormously from the discoveries that flow from understanding this rare phenomenon. Philosophical and existential reflections. What does it mean for us? Beyond the scientific and technological implications, the discovery of the rarest thing in the universe also has deep philosophical and existential implications for humanity. It forces us to grapple with some of the oldest and most profound questions about life, existence, and our place in the cosmos. The discovery reminds us of the vastness and complexity of the universe and the mystery that still remains in the depths of space. While we have learned much about the cosmos, there is still so much that is hidden, waiting to be uncovered. The rarest thing in the universe is not just a discovery. It is a reminder that there is always more to learn, more to explore, and more to understand about the world around us. In the face of such vastness, humanity is forced to reflect on its own existence. What is our role in the universe? Are we just one fleeting moment in the grand cosmic timeline, or do we have the potential to make a lasting impact? This discovery invites us to think about the future of humanity and the legacy we will leave behind. It encourages us to embrace curiosity, exploration, and the pursuit of knowledge as guiding principles for our future. The future of humanity's cosmic journey. The discovery of the rarest thing in the universe sets the stage for the next phase of humanity's cosmic journey. It shows us that there is still so much more to discover, and that our current understanding of the universe is only the beginning. The pursuit of knowledge and exploration will continue to drive us toward new frontiers, whether it's exploring the farthest reaches of space or understanding the deepest mysteries of existence. As we move forward, this discovery will inspire future generations of scientists, engineers, and thinkers to reach further, to dream bigger, and to challenge the boundaries of what is possible. The rarest phenomenon will serve as a constant reminder of the power of human curiosity and the infinite possibilities that await us in the universe. It will fuel the desire to explore the unknown and push the limits of scientific and technological achievement. Ultimately, the discovery of the rarest thing in the universe is not just about the object or phenomenon itself. It's about the impact it has on us as a species. It challenges us to look beyond our own limited perspective and embrace the vastness of the cosmos. It invites us to reflect on the questions that have defined humanity for centuries. What is the nature of life? How do we fit into the universe? And what lies beyond the boundaries of what we can see and understand? Conclusion: the beginning of a new era. The discovery of the rarest thing in the universe is just the beginning. It opens up new realms of scientific inquiry, technological innovation, and philosophical exploration. It has the power to redefine humanity's understanding of its place in the cosmos and inspire future generations to continue the search for knowledge. As we continue to explore the universe and study the rarest phenomenon, we will undoubtedly uncover more mysteries and more truths about the nature of reality. But more than that, we will be reminded of the power of curiosity, the desire to explore, and the endless possibilities that lie ahead in the ever-expanding journey of discovery. While the discovery of the rarest thing in the universe is a monumental breakthrough, it is far from the only extraordinary phenomenon in the cosmos. The universe, with its infinite expanse and countless mysteries, continues to surprise and challenge our understanding of reality. For every rare object or event we uncover, there are countless others waiting to be discovered, each one offering unique insights into the nature of space, time, and existence. In this chapter, we'll explore other rare phenomena in the universe, comparing them to the recent discovery and discussing what makes them significant in their own right. Some of these rare phenomena are well known to the scientific community, while others remain the subject of intense speculation and exploration. From the most distant galaxies to the most bizarre quantum events, the universe is teeming with rare and unexplained occurrences that continue to challenge the boundaries of science. By studying these anomalies, we gain a deeper understanding of the universe's vast complexity and its many hidden layers. 1. The mystery of dark matter. One of the most enigmatic phenomena in the universe is dark matter, a form of matter that we cannot directly observe but know exists because of its gravitational effects on visible matter. Dark matter makes up about 27% of the universe's total mass, yet it is invisible to telescopes. It does not emit, absorb, or reflect light, and it doesn't interact with electromagnetic forces in any detectable way. Instead, it exerts a gravitational pull on ordinary matter, influencing the formation of galaxies and galaxy clusters. Despite its presence in many of the universe's most massive structures, dark matter remains one of the greatest mysteries in cosmology. Its elusive nature has made it extremely difficult to study, and scientists have yet to directly detect any dark matter particles. The discovery of this rare phenomenon, the rarest thing in the universe, could offer new insights into dark matter. If the object discovered is related to dark matter, it could shed light on the fundamental properties of this mysterious substance and provide the breakthrough that physicists have been searching for. Scientists have proposed many different candidates for dark matter particles, including WIMPs, weakly interacting massive particles, and axions, but no definitive detection has been made. The discovery of a rare phenomenon linked to dark matter could provide a direct observation of these particles or reveal an entirely new form of matter that interacts with regular matter in ways we had not anticipated. 2. Gravitational waves, the ripples in space-time. Gravitational waves are ripples in space-time caused by some of the most violent and energetic processes in the universe. Predicted by Albert Einstein in his theory of general relativity, these waves travel at the speed of light, carrying information about their sources, such as merging black holes or colliding neutron stars. Until recently, gravitational waves were purely theoretical, with no direct evidence of their existence. However, in 2015, scientists made a groundbreaking discovery when the LIGO, Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time. The waves were produced by the merger of two black holes, a cataclysmic event that created ripples in space-time that stretched and compressed the fabric of space itself. This discovery confirmed a major prediction of general relativity and opened up a new way of observing the universe. The detection of gravitational waves has since become one of the most significant breakthroughs in modern astrophysics, allowing us to study black holes, neutron stars, and other extreme cosmic events in ways that were previously impossible. But gravitational waves are still rare occurrences, and their detection remains a complex and precise process. As more gravitational wave events are detected, scientists hope to uncover even more about the most violent processes in the universe. The rare phenomenon recently discovered could even offer new insights into how gravitational waves are produced or provide further evidence of previously unknown phenomena related to spacetime. 3. Neutron stars, the densest objects in the universe. Neutron stars are among the most fascinating and extreme objects in the universe. These stars are the remnants of massive stars that have exploded in supernovae, leaving behind incredibly dense cores composed almost entirely of neutrons. The density of a neutron star is mind-boggling. Just a single teaspoon of neutron star material would weigh about 6 billion tons. Neutron stars are incredibly compact, with a mass greater than the Sun, but a diameter of only about 10-20 kilometers. What makes neutron stars so rare and fascinating is their extreme environment and the bizarre physics that occur within them. The conditions inside a neutron star are so extreme that matter behaves in ways that are completely foreign to our understanding of physics. For instance, the magnetic fields of neutron stars can be millions of times stronger than the strongest magnetic fields found on Earth, and the temperatures can reach millions of degrees. Some neutron stars are also known to emit pulses of radiation at regular intervals, a phenomenon known as pulsars. Pulsars are incredibly regular in their emissions, and their study has allowed scientists to test aspects of physics in ways that are not possible in less extreme environments. Pulsars are a rare and valuable tool for studying the laws of physics, and their study continues to yield insights into general relativity, quantum mechanics, and the behavior of matter in extreme conditions. While neutron stars are rare, stars are, and extreme objects in their own right. The discovery of a rare phenomenon associated with them, such as a pulsar in an unusual state or a neutron star with an unusual form of matter, could offer new insights into their behavior and the forces at play inside these bizarre cosmic objects. 4. Supermassive black holes, the mysterious giants of the cosmos. Supermassive black holes are among the most mysterious and powerful objects in the universe. These black holes, which are millions to billions of times the mass of the Sun, sit at the centers of most large galaxies, including our own Milky Way. Supermassive black holes exert a tremendous gravitational pull, influencing the orbits of stars and even entire galaxies. They are thought to play a central role in the evolution of galaxies, regulating star formation and shaping the overall structure of the cosmos. What makes supermassive black holes so rare and intriguing is their mysterious origin. Scientists have long debated how these giants form. Some believe that they form from the merging of smaller black holes, while others think they might be the result of direct collapse of massive gas clouds. The recent discovery of a rare phenomenon related to black holes could shed light on their formation and behavior, helping scientists unlock the secrets of these cosmic giants. In addition to their mystery, black holes are also sites of extreme gravitational phenomena, where space-time is warped to such an extent that even light cannot escape. This makes them incredibly difficult to study, as any information that falls into a black hole is lost to us. However, through gravitational wave detection and high-energy observations, scientists have begun to learn more about these enigmatic objects, and the discovery of the rarest thing in the universe could provide further clues about how supermassive black holes influence their surroundings. 5. Cosmic voids, the empty spaces between the stars. The vast majority of the universe is made up of empty space, regions where matter is sparsely distributed or entirely absent. These cosmic voids are some of the largest structures in the universe, stretching for hundreds of millions of light years. They are not truly empty, as they contain gas, dust, and dark matter, but they are significantly less dense than the regions between galaxies. Cosmic voids are rare in the sense that they represent areas of extreme emptiness, vast regions of space where there is very little matter and little interaction between galaxies. The study of cosmic voids can provide valuable insights into the large-scale structure of the universe, the expansion of space, and the effects of dark energy. The discovery of the rarest phenomenon in the universe could help explain the origin and evolution of cosmic voids, revealing how they grow and interact with the rest of the universe. This could have profound implications for our understanding of the cosmos's future and its ultimate fate. 6. Exoplanets. The search for life beyond Earth. One of the most exciting areas of modern astronomy is the search for exoplanets, planets that exist outside our solar system. As of today, thousands of exoplanets have been discovered, and many of them lie in the so-called habitable zone, the region around a star where conditions might be right for liquid water to exist. The discovery of exoplanets in this zone raises the tantalizing possibility of life beyond Earth. While the discovery of exoplanets is far from rare, the search for planets that could support life is still one of the most important and exciting areas of study. The rarest thing in the universe could be a new type of exoplanet or a discovery related to the conditions required for life. For example, the discovery of a planet with a unique atmosphere, magnetic field, or geological composition could offer new insights into the potential for life in the universe. Conclusion: the rarest phenomena and the future of discovery. As we continue to study the rarest thing in the universe, it's important to remember that the cosmos is filled with other rare and fascinating phenomena that challenge our understanding of reality. From the mysterious nature of dark matter to the extreme environments of neutron stars and black holes, the universe is a treasure trove of objects that defy our expectations and force us to reconsider the boundaries of science. The discovery of the rarest thing is just one piece of the puzzle, and as we continue to explore the cosmos, we will undoubtedly uncover more mysteries that will continue to shape our understanding of the universe. Each discovery brings us closer to understanding the fundamental forces that govern everything from the smallest particles to the largest cosmic structures, and the rarest phenomena in the universe serve as a reminder that there is always more to explore. The discovery of the rarest thing in the universe has not only expanded our understanding of the cosmos, but has also opened up countless avenues for future research. While this groundbreaking event has already reshaped our views on physics, cosmology, and the forces that govern the universe, it is far from the end of the journey. In fact, it is just the beginning. The questions raised by this discovery are vast, and the scientific community is just starting to scratch the surface of the implications. As we delve deeper into understanding this rare phenomenon, the discoveries that follow may be even more profound, offering new insights into the most fundamental aspects of the universe. In this chapter, we will explore the next steps in the research sparked by this groundbreaking discovery. From the technological advancements that will allow us to study the phenomenon in more detail to the theoretical frameworks that will evolve. As a result, we will discuss the exciting future of scientific exploration in the wake of the discovery of the rarest thing in the universe. Expanding our observational capabilities. The first and most immediate step following the discovery of the rarest thing in the universe is to improve our observational capabilities. While current technology allowed for the detection of this rare phenomenon, it is clear that to truly understand its properties and its role in the universe, we will need to develop more advanced tools. The rarity and elusive nature of the phenomenon mean that we cannot rely on existing instruments alone. We must push the boundaries of what is possible in observational technology. One of the most promising areas for future development is the improvement of gravitational wave detection. The discovery of the rarest phenomenon might be linked to the generation of gravitational waves, which are ripples in the fabric of space-time created by some of the most extreme cosmic events. These waves can travel vast distances across the universe without being blocked or absorbed, making them an invaluable tool for studying distant objects and phenomena. Gravitational wave observatories like LIGO and Virgo have already revolutionized our understanding of black holes, neutron stars, and other dense objects. However, as we seek to explore more elusive phenomena, like the rarest thing in the universe, we will need to enhance the sensitivity and precision of these instruments. New detectors, such as the LISA, Laser Interferometer Space Antenna, mission, which will operate in space, are being developed to detect lower-frequency gravitational waves that current ground-based detectors cannot reach. These advancements will enable scientists to observe more distant or more subtle events that might be linked to the rare phenomenon. In addition to gravitational wave detection, radio astronomy and optical telescopes will continue to play a vital role in future research. Instruments like the James Webb Space Telescope, JWST, which is set to launch with advanced infrared capabilities, will provide unprecedented views of distant galaxies and the regions where the rare phenomenon is believed to reside. With its ability to detect faint signals from deep space, JWST will allow scientists to study the rarest phenomenon in greater detail, potentially uncovering new aspects of its behavior and interactions with the surrounding environment. Theoretical research, new models and hypotheses. While the discovery of the rarest thing in the universe has already forced a rethinking of many established theories, the true impact of the find will only be realized once new theoretical models are developed. The discovery is likely to inspire an entire field of research dedicated to understanding the phenomenon and its implications for our understanding of fundamental physics, cosmology, and even the nature of space and time itself. One of the first areas of theoretical research will focus on understanding how the rare phenomenon fits into existing models of dark matter, dark energy, and quantum mechanics. For instance, if the UTI phenomenon is related to dark matter, it could lead to a re-examination of current models that describe how dark matter interacts with regular matter. This could open up new avenues for detecting dark matter directly and could even lead to the discovery of new dark matter particles. Similarly, if the phenomenon is tied to dark energy or has implications for the accelerated expansion of the universe, it could reshape our understanding of the forces driving this expansion. The discovery could lead to the development of new theories of cosmic inflation, the rapid expansion of the universe that occurred just after the Big Bang, and could provide new insights into the nature of space-time itself. Additionally, the discovery could help address some of the most profound unanswered questions in physics, such as the nature of gravity and how it interacts with quantum mechanics. One of the ultimate goals of modern physics is to reconcile general relativity, which describes gravity on large scales, with quantum mechanics, which describes the behavior of particles on the smallest scales. The rare phenomenon could offer insights into how these two fundamental theories fit together, potentially providing a path toward the long-sought theory of everything that unifies all forces in the universe. New discoveries. Uncovering more phenomena. While the rarest thing in the universe may be the discovery that changes everything, it is also a signpost pointing toward even greater revelations. Scientific discoveries are rarely isolated. Each new breakthrough tends to open up new questions, leading to even more discoveries. The detection of the rare phenomenon may be just the first of many extraordinary finds that will reshape our understanding of the universe. One of the most exciting prospects following this discovery is the potential for finding other similar phenomena. As our observational techniques improve and we expand our understanding of the universe, we may discover more rare objects or events that share characteristics with the phenomenon we have already uncovered. These new discoveries could lead to a deeper understanding of the fundamental forces at play in the cosmos and could reveal patterns or relationships that were previously unknown. For example, the rare phenomenon may be part of a class of objects or events that we have not yet fully classified. The scientific community will likely begin searching for other instances of this phenomenon, whether it involves similar gravitational effects, electromagnetic signatures, or interactions with dark matter. By finding more examples of the rare phenomenon, scientists will be able to refine their models and build a more comprehensive picture of how this type of object or event fits into the larger structure of the universe. The search for life beyond Earth. New implications. Another area where this discovery could have profound implications is in the search for life beyond Earth. While this phenomenon is not directly related to extraterrestrial life, it could provide new insights into the conditions necessary for life to arise in the universe. By studying the rare phenomenon, scientists may uncover new information about the environments where life might exist, whether on other planets or in other galaxies. If the rarest phenomenon is linked to the fundamental building blocks of the universe, such as the formation of galaxies, stars, or planets, it could help scientists understand the processes that lead to the creation of habitable environments. This could inform the search for exoplanets in the habitable zone, the region around a star where liquid water can exist, one of the key ingredients for life as we know it. Moreover, by understanding how the rare phenomenon interacts with its environment, scientists might gain insights into the types of energy, chemistry, and conditions that could support life. This could lead to the development of new technologies or methodologies for detecting life on distant planets, bringing us one step closer to answering one of humanity's most enduring questions. Are we alone in the universe? The broader impact on technology and society. As the research into the rarest phenomenon continues, it will likely have far-reaching implications for technology and society. The tools and techniques developed to study this discovery could be adapted for use in other areas of science, medicine, and engineering. For example, advancements in gravitational wave detection, quantum computing, and space exploration could all benefit from the new research inspired by this discovery. In addition, the discovery could inspire a new generation of scientists, engineers, and explorers, fueling further advances in technology and space exploration. As we continue to study this rare phenomenon and its implications, it will likely catalyze the development of new technologies that could have real-world applications, from energy generation to communication, and even the next generation of space missions. The potential societal impact of this discovery is profound, as it highlights the power of scientific curiosity and exploration. It shows us that, even in an era where we have already made tremendous strides in understanding the cosmos, there is still much to learn and explore. It is a reminder that the universe is full of mysteries waiting to be uncovered, and the pursuit of knowledge is an ongoing journey that will continue to shape our future. Conclusion. The path ahead. The discovery of the rarest thing in the universe is a monumental achievement, but it is also just the beginning. The next steps in research will build upon this discovery, pushing the boundaries of what we know and leading to new breakthroughs in technology, science, and our understanding of the cosmos. As we continue to explore the universe, we will uncover more mysteries, pose more questions, and ultimately make more discoveries that will change everything we know. The implications of this discovery are vast, and the journey ahead promises to be as exciting and transformative as the discovery itself. The universe has revealed a new chapter, and humanity stands on the threshold of a new era of exploration, understanding, and discovery. The rarest phenomenon may have been found, but the future holds the promise of even greater revelations, and humanity's role in this cosmic journey is just beginning. The discovery of the rarest thing in the universe is not merely the conclusion of one journey, but the spark for an entirely new chapter in the ongoing exploration of the cosmos. As we've explored throughout this journey, the implications of this discovery extend far beyond the confines of one scientific breakthrough. They are a window into a broader understanding of the universe and the fundamental forces that shape reality. From redefining established physics to sparking new technological advancements, this discovery challenges everything we thought we knew. And in doing so, it opens the door to even more questions, more exploration, and more awe-inspiring revelations. In this final chapter, we will reflect on the importance of the discovery, summarize its far-reaching implications, and look ahead to what comes next. The pursuit of knowledge is never truly complete, and each discovery leads to new insights, new mysteries, and new opportunities for scientific advancement. The rarest phenomenon in the universe is a stepping stone, not an endpoint. It is a symbol of the limitless potential for exploration that lies ahead. The nature of scientific discovery. Constant evolution. Scientific discovery is not a linear process. It is a journey of continuous evolution where each breakthrough leads to new questions, new hypotheses, and new avenues for investigation. The discovery of the rarest thing in the universe serves as a powerful reminder of the ever-changing nature of science. What we know today is always subject to revision as new data, new observations, and new technologies emerge. This is the beauty and the challenge of science. It is never static, and it is always in flux. What makes this particular discovery so significant is not just its rarity, but the way it has the potential to reshape entire fields of study. As we've seen throughout this script, the implications extend to everything from our understanding of dark matter and dark energy to our theories about the origins of the universe and the behavior of gravity. This discovery forces us to rethink fundamental principles, offering new models, new possibilities, and new ways of understanding the cosmos. The rarest thing in the universe has become a focal point for the future of scientific inquiry, an object of study that will continue to challenge scientists for decades, if not centuries, to come. The drive for exploration, humanity's unyielding curiosity. At its core, the pursuit of scientific discovery is driven by humanity's unyielding curiosity. We are wired to explore the unknown, to seek out the mysteries that lie just beyond our reach, and to answer questions that have plagued us for generations. This innate drive to explore and understand the universe is what has led to every major breakthrough in human history. Whether it was Galileo peering through a telescope to study the stars or the development of quantum mechanics, each step in human progress has been fueled by the desire to know more about the world around us. The discovery of the rarest thing in the universe is no exception. It represents the culmination of years of exploration, technological innovation, and scientific perseverance. Yet, like every discovery before it, it also marks the beginning of a new phase of inquiry. It is not just the end of one search, but the initiation of many more. The questions raised by this discovery are not only scientific, but philosophical, questions that will shape the future of humanity's understanding of itself and its place in the universe. New frontiers in technology and innovation. While the discovery of the rarest thing in the universe may seem to be a purely scientific achievement, it will undoubtedly have profound implications for technology and innovation. The tools and methods used to uncover this phenomenon have already led to significant advancements in observational astronomy, quantum physics, and other scientific fields. As we continue to develop the technologies necessary to study this discovery in greater detail, we will likely see a ripple effect in other areas of research. For example, the technologies developed for gravitational wave detection, radio astronomy, and space-based telescopes will likely have far-reaching applications in fields beyond astronomy. Gravitational wave detection, for example, could lead to advancements in precision measurements and quantum computing, while radio astronomy could provide new tools for communication and imaging. As scientists continue to study the rarest thing in the universe, they will undoubtedly encounter new challenges that will require innovative solutions. These solutions, in turn, will spur new technological developments that will impact industries far beyond space exploration. Moreover, the study of dark matter, dark energy, and other cosmic phenomena will likely lead to breakthroughs in energy generation and material science. Understanding the nature of these mysterious forces could unlock entirely new forms of energy or new methods of harnessing power. Technologies that stem from this research could change the way we generate and store energy on Earth, leading to a more sustainable and energy-efficient future. The ripple effect. How one discovery can change everything. The rarest thing in the universe is not an isolated phenomenon. It is part of a larger network of discoveries that have transformed our understanding of the cosmos. Each discovery, whether it's the detection of a distant exoplanet or the detection of gravitational waves, contributes to the growing body of knowledge about the universe. The more we learn, the more we realize how much we don't know, and this paradox drives us forward. The rarest phenomenon discovered represents one of the most profound revelations in the history of science. Its rarity and complexity have already forced scientists to reconsider established models of physics, and it will continue to do so for years to come. But beyond its scientific importance, this discovery will have a ripple effect on other fields of research and on society as a whole. By asking new questions and challenging established theories, this discovery will inspire the next generation of scientists, engineers, and thinkers to tackle even greater mysteries. It will push humanity to explore new frontiers in physics, astronomy, and technology, sparking innovation and creative problem-solving. It will be a catalyst for a new wave of scientific curiosity, one that is driven not just by the pursuit of knowledge, but by the desire to understand our place in the cosmos. A new era of exploration and understanding. The discovery of the rarest thing in the universe has ushered in a new era of scientific exploration. The universe is vast, and there are still many mysteries left to uncover. While the discovery of the rarest phenomenon represents a monumental breakthrough, it is only the beginning. As scientists continue to explore the implications of this discovery, they will uncover more secrets that could transform our understanding of reality itself. This new era of exploration will be marked by a combination of cutting-edge technology, interdisciplinary collaboration, and an unyielding drive to push the boundaries of knowledge. The next generation of scientists will be tasked with building on the discoveries made today, taking us further into the unknown and challenging us to think in new ways. As we look ahead, it is important to recognize that the journey of scientific discovery is ongoing. The rarest thing in the universe has opened a door to new possibilities, but there are many more doors waiting to be opened. The future of science is filled with untold potential, and each new discovery will build on the last, creating a legacy of knowledge and understanding that will continue for generations to come. Conclusion: a journey without end. The discovery of the rarest thing in the universe is a monumental moment in the history of science, but it is also a testament to the enduring power of human curiosity and exploration. It shows us that there is always more to discover, always more to understand, and always more to explore. As we move forward, we will continue to ask new questions, confront new challenges, and seek new truths about the universe. This discovery is a reminder that science is a journey, one that is never truly complete. As we continue to study the rarest phenomenon, we will gain new insights into the nature of the universe and the forces that govern it. And as we unlock these mysteries, we will be reminded that the universe is far stranger, more complex, and more awe-inspiring than we ever imagined. The journey of discovery is never-ending, and with each new breakthrough, we are one step closer to understanding the vast, unfathomable cosmos that we call home.